For countless generations, humanity has tilted its head back and stared at the night sky in wonder. Across deserts, oceans, and mountain peaks, people from every culture have looked up into the same darkness, seen the same glimmering lights. The stars were our first teachers. They taught us to measure time, to navigate oceans, to dream beyond the horizon. In that darkness, our ancestors drew meaning from scattered points of light. They linked the stars into hunters and beasts, serpents and gods. They watched the planets drift across the fixed backdrop of stars and called them wanderers, their motion mysterious and unsettling. The sky became a living tapestry of myths, heroes battling monsters, divine beings waging cosmic wars. It served as both our map and our mirror, reflecting our hopes, our fears, and our search for belonging. Yet behind every story scratched into stone or inked onto parchment pulsed a single question, deeper than any legend. In all this vastness, are we truly alone? That question has been a quiet engine driving our curiosity across the ages. Each new tool widened our cosmic horizon. Each discovery peeled away another layer of mystery. Every advance, from polished bronze instruments to radio dishes spanning fields, was a small step toward an answer. The first telescopes revealed Jupiter's moons, tiny worlds circling a giant, proving that Earth was not unique. Radio antennas captured faint signals from galaxies far beyond our own, stretching our view to the edge of the observable universe. We learned that galaxies collide and merge like living organisms, that stars explode in violent deaths, and that black holes lurk unseen, devouring anything that ventures too close. Piece by piece, our picture of the cosmos became richer, stranger, and more humbling. And now, the James Webb Space Telescope, humanity's most ambitious eye on the cosmos, has given us a view our ancestors could never have imagined. It does not merely show pinpricks of light. It opens a window onto other worlds. It allows us not just to look at the heavens but to listen to them, to decode their ancient messages. Webb sits a million miles from Earth at a delicate gravitational balance point, like a jewel suspended between the pole of worlds. Freed from the distortion of our atmosphere, it watches in silence, collecting the faintest threads of ancient light. Its mirrors, thin as spider silk yet strong as steel, are plated in gold and unfold like a flower in the vacuum of space. They catch light that left its source billions of years ago, before humanity, before Earth's oceans, before life itself. Light that crossed galaxies, slipped past dying stars, drifted through darkness, and finally reached Webb's gleaming petals. Webb doesn't just gather light. It splits it, spreads it into colors and patterns, reading the hidden chemical fingerprints within every photon. Every beam of starlight becomes a messenger. Every faint pattern a story waiting to be unlocked. Those stories tell of galaxies being born, suns burning out, and the possibility of alien skies. Astronomers expected Webb to refine what we already knew. To sharpen our view of distant galaxies, to measure exoplanet atmospheres with greater precision, to probe the fading afterglow of the Big Bang. It has done all of that brilliantly. But it has also given us something more, something unexpected. It has not just deepened our knowledge, it has shaken our assumptions. Webb is not simply a telescope. It is a breaker of old beliefs. And its latest discovery may be its most astonishing yet. This time it has not merely spotted another exoplanet. It has revealed a world alive with potential. This world is a super-Earth, orbiting a small red star only 40 light-years away. Close enough to glimpse, far enough to remain mysterious. Larger than Earth but not a gas giant, it is rocky and solid under alien skies. Its gravity can hold an atmosphere, yet it is light enough to imagine standing on its surface, feeling the pull of its stronger gravity beneath your feet. It sits in its star's habitable zone, the fragile region where liquid water can persist. Using its instruments like a prism held to alien skies, Webb analyzed the planet's atmosphere. The results stunned astronomers: water vapor, methane, carbon dioxide, and oxygen. Individually, these molecules are common. Together, in the ratios Webb detected, they tell a different story, a story of imbalance like Earth's. On our planet, oxygen and methane destroy each other unless life continually replenishes them. Plants release oxygen. Microbes release methane. Life maintains the imbalance. Now, 40 light-years away, the James Webb Space Telescope has traced that same fragile chemical rhythm, a pattern of gases balanced in ways nature rarely maintains alone. It could be the first soft whisper of life beyond our world, a biological heartbeat encoded in light that has traveled across the darkness of interstellar space. For generations, the question has echoed through science and story alike. If life can exist here, with all its delicate balances and improbable coincidences, why not elsewhere? And Webb's discovery may be our first glimpse of that elsewhere. But what makes these so-called super-Earths so magnetic to our imagination? Their very scale gives them endurance. They are planets 1 to 10 times Earth's mass, worlds heavy enough to cling to thick atmospheres, to cradle their oceans for billions of years, to survive the tantrums of their stars when smaller worlds might be stripped bare. Some simulations even suggest they could be more stable than Earth. Gentler tides, slower tectonic drift, climates that barely change for eons. A paradise built not from perfection, but from persistence. Yet this particular world is far from gentle. It hides a dramatic truth: it is tidally locked. One face forever burns beneath its parent star's crimson glare, the other remains buried in an endless, frozen night. At first, this seems like a planet divided against itself, a realm of fire and ice, where life should have no chance to thrive. But nature often finds balance in chaos. Computer models suggest that a dense, circulating atmosphere could ferry warmth from day to night, spreading energy across the globe. Between extremes, along the narrow boundary where dusk never ends, a twilight belt may exist, a ring of eternal evening. Here, under skies painted with a permanent sunset, oceans could shimmer, clouds could drift in slow motion, and temperatures might hover at the edge of comfort. It is a place of equilibrium, a border between light and darkness, perhaps the only region where life could awaken. Imagine standing there. Above you, a dim red sun forever fixed near the horizon, casting long golden shadows that never fade. To one side, the inferno of daylight glows on the horizon. To the other, the night stretches into a continent of ice. Winds sweep across the surface, carrying the scent of alien seas, their sound mingling with the low hum of storms that never cease. What kind of life could rise in such a world? Perhaps compact, muscular beings built to withstand the heavier pull of gravity. Perhaps vast mats of photosynthetic organisms, feeding on the soft red light that seeps from the star. In the endless twilight, forests of glass like leaves could shimmer with ruby reflections. On the dark side, creatures might glow with inner light, bioluminescent bodies tracing slow arcs through black oceans, their movements forming constellations beneath the waves. Some might navigate not by sight, but through magnetism, feeling the planet's field as we feel sunlight on our skin. Predators, prey, and symbiotic forms may all exist there, bound by rules of biology utterly unlike our own. Life writing its story in a new alphabet of chemistry and light. And this vision is not fantasy born of hope. It is grounded in evidence, in starlight that has passed through an alien atmosphere and reached our telescopes as a coded message. Webb's instruments detect faint shifts, minute variations in gas, subtle chemical asymmetries, seasonal fluctuations that defy purely geological explanation. These could be signs of volcanoes, complex reactions, or something more profound, the quiet respiration of a living planet. That possibility redefines everything we thought we knew about solitude. It transforms astronomy into philosophy. Because if even a single other biosphere exists, then life is not an accident of Earth. It is a cosmic pattern, woven into the fabric of creation itself. And so a new question emerges. If we are no longer alone, what comes next? Do we watch in silence, careful not to disturb a fragile world we barely understand? Do we send a signal, hoping to be heard by minds we cannot imagine? Stephen Hawking once warned that contact could be dangerous, that civilizations meeting across the stars might repeat the mistakes of history, where the powerful consumed the vulnerable. Others argue that communication is inevitable, that curiosity itself is our defining trait, and that silence would deny the very impulse that built telescopes, rockets, and dreams. Meanwhile, our own broadcasts have already escaped into the void, radio, television, radar, all racing outward at the speed of light. If someone there has the means to listen, they may already know we exist. Perhaps, beneath their dim red sun, another civilization has noticed a pale blue flicker among the stars. Perhaps they are watching us now, asking the same question that has haunted humanity since the dawn of thought. Are we alone?